Welcome students. This video lecture is a part of Force Public School Digital Learning Program. Today we continue our chapter 4, that is chemical bonding. Today we discuss the very important theory of this chapter, that is valential electron pair repulsion theory. यहाँ इसके नाम में repulsion लिखा हुआ है. That means we talk about different kind of repulsion here. कितने टाइप के repulsions होते हैं? How repulsion is so important to decide the geometry of a molecule. That theory was first proposed by Powell and later is reformulated by the Gillespie and Nylons. So basically, discovery of this theory is goes to Gillespie and Nylons. So what are the basic postulates about this theory? The shape of molecule is decided by number of lone pairs and bond pairs around the center atom. Suppose there is a ammonia molecule that having chemical formula NH3. So the central atom is nitrogen here. Okay. So the shape of the ammonia molecule, geometry of the ammonia molecule is decided by number of lone pair and non pair molecules. First postulate is explain this. Second one is pair of electrons repel each other because they are negatively charged. If you see electron pairs, then there are two kinds of electron pair. One is lone pair, another is bond pair. Both the pairs of electrons are having electrons, and electrons are basically have negative charge. If both are having negative charge, then there is a repulsion existence. Next is third. These electron pairs arrange in space in such a way to minimize repulsion. That means इलेक्ट्रॉन पेयर जो है लोन पेयर एंड बॉन्ड पेयर उस तरीके से अरेंज होंगे स्पेस के अंदर एडजस्ट करेंगे इससे रिपल्शन कम से कम फील हो. नेक्स्ट इज फोर्थ वन. Multiple bond is treated as a simple single pair. That means whether it is a double or triple bond, they are considered to be a single supra pair. So presence of double and triple bonds never affect the geometry of the molecule. The fifth one is the order of repulsion. If we see the order of reaction, then what we see, the maximum repulsion is observed in lone pair repulsion, then lone pair bond pair repulsion, and basically the least repulsion is observed in a bond pair repulsion. Okay. Come to the next. What are the different kind of molecules that can be observed or separate according to Vesper? So according to valential electron pair repulsion theory, which classify all the molecules into two categories, broad categories. These are uh, molecules with the regular geometry and molecules with the irregular geometry. What is the basic theme to classify these two different kind of molecules? They are based on that if there are lone pairs which are present on the center atom, then they are classified as a irregular type of molecule. There is no lone pair on the center atom of a molecule, then they are treated as a regular geometry containing molecules. So what we see, regular molecules and irregular molecules. We have two separate tables for the both kind of molecules, regular as well as irregular. So what is the basic definition for the regular molecules? Molecules which do not have lone pairs on the center atoms, like methane, like BeCl2, like BF3. So these are the molecules which do not have any lone pair on center atom. Come to the next, that is irregular type of molecules. Molecules which have lone pair on the center atom are called irregular type of molecules. The central atom possesses lone pair of electrons may undergo repulsion, and that repulsion may be responsible for deciding their geometries in space. So have a look on this different kind of regular molecules. Then what we see, first type is Ab2 type, that is represented by a molecule BeCl2 correctly. The shape of the molecule is linear and the geometry you have to see here. So there is an angle, that angle is 180 degree. Okay, if you see, the angle become 180 degree. What we observe, we observe the angle, that angle is 180 degree because it is quite 180 degree angle. Okay, suppose we have to see because there is an absence of lone pair, so this is the only way where both the bond pairs are having least repulsion. Only situation. We have three bonds, bond pairs, then how they arrange in space. As you can see here, for the angle between them is of 120 degree. Okay, you can see here the angle become 120 degree. Yes, like that. So its geometry become triangular planar because all these three atoms are lying on the same plane. As similar, if you have four bond pairs, then their geometry must be tetrahedral, and for the AB5 molecule, geometry become trigonal bipyramidals, and for the SF6 like molecule, it became octahedral. So what you see basically all the molecules which are we use here for the examples, they do not have any lone pair on their center atom. Okay. And if we see the angles, value of angles that are lying between two bond pairs, what we observe, the angle between tetrahedron bond pairs is 109 degree and 4 minutes. And, and what about the trigonal bipyramidal? There are three atoms like 1, 2, and 3. There are two different kind of angles. Okay, you can see here. So first of all, these two axial bonds and the angle between these two axial bonds, that is 180 degree, that is 180 degree, and there is another one between two. These three bonds are lying in the plane and having angle 120 degree here. There is another angle between axial and equatorial, that is 90 degree. So basically, in trigonal bipyramidal, there are three different kind of angles. One is in between equatorial, one in between axial, and one in between equatorial and axial. But in case of octahedron, second thing is very important. Why it is called trigonal bipyramidal? Because if we connect all the apex of these one, then what we see a pyramid here. One, two, three. आप जब आपसे connect करेंगे, आपको यहाँ pyramid नजर आएगा. देखिए, connect all the effects. What you see the pyramid. Erase and draw again. Here, connect the effects of all the here, line effects, or that is three effects. If we connect all these effects, then we got a pyramid here and one pyramid at the bottom side. Basically, this is all about the geometry of regular molecule. We see the irregular molecules. You can see here there is a E notation for the lone pair. If there is no lone pair on the center atom, that is regular molecule, and that can represent as E note. That is PeCl2, AgCl2. So this table contains regular as well as irregular molecule. The first one is regular molecule, second one is irregular, then irregular. Okay, lone pair make their geometry that shows some deviation from regular arrangement. As similar, E node is a normal trigonal planar. That means it is a your regular molecule. So I encircle the regular molecule with the help of pointer. You can see here. This is your regular molecule. Okay, this is your again regular molecule. This is again your regular, not a regular. This is your regular molecule. This is irregular. So how you find this regular or irregular molecule? Because there is a E1. E1 means there is one lone pair is present. That lone pair is represented by this yellow type atoms. Okay. Now, what are the limitations for the Vesper? You can see here. This theory fails to explain isoelectronic species despite they are having same number of electrons, that means same number of bond pairs, same number of lone pairs, even their geometry is different, their orientation are different. So what is the logic behind it? That theory will never explain. Second is fails to explain magnetic and color properties. Vesper theory never explains the magnetic properties and the color properties of compound, that will later explained by the molecular orbital theory. तो हर थ्योरी यहाँ पर कोई गलत नहीं है, सारी थ्योरीज कुछ ना कुछ नया रिप्रेजेंट करती है, एक्सप्लेन करती है, सभी थ्योरीज अच्छी है, सपोर्टिव है सब. Yes, so this is all are about today lecture. We have some important questions that are based on today topic. So you have to complete this question on the same date. You may also write in your notebook. So that I already discussed about the different kind of angles that are present in between axial, 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 equatorial, and equatorial, equatorial. Second question, write any two limitations that we already explained. Electron pairs are of two types, one is lone pair, another is one pair, that we already discussed. Fourth question is so important and most of the time seen in examination. PCl axial bond length is greater than PCl5 equatorial. जो axial वाली जो bond length होती है वो ज़्यादा लंबी होती है as compared to equatorial bond length. The reason is due to lone pair and lone pair repulsion. So this is all about today's lecture. Have a nice day and thanks you for seeing watch this video.